Hey guys, welcome to another video. So today we continue on with the nice question series of videos that I'm releasing. Today's question comes from the complex numbers topic in the Extension 2 syllabus. One of my favorite questions, very common in terms of structure and approach, so quite a good question for me to cover. Before we begin, if you haven't already done so, as always, guys, like the video, subscribe to the channel if you haven't, and tell your friends. So let's get started. The question comes from James Roos in 2004, but it's been used over and over again by different schools over the last year. I might have even started from James Roos, might be somewhere else, but it's a very common question. Look at the structure of the question. It basically roots of unity, power of 5 minus I. I like the fact that it minuses I because the really easy questions minus 1, right? And it's really straightforward thereafter. But when it minuses something else, in this case I, it gives different angles and it gives different answers, right? But thereafter, the questions are fairly stock standard, aren't they? Show that that factorization goes to 0, find all roots in cis form, solve that, so show that it factorizes into products of linear and quadratic real terms and then exact values, right? So 10 marks though, right? In a test out of 100, so that's 10% of the test. Quite a lot of marks for this. So let's get started. Quite excited for this question. Quite enjoy doing it, right? So the question begins with Z5 minus I equals 0, right? So then we basically factorize that. So it's minus I, just to be absolutely clear, right? It's the same as like I to the power of 5, right? Because that's like I4 times I4 times I, right? So then that's just difference of 2 quintics, right? So it'd be Z minus I. And you guys know this, right? So it'll be minus, and then when we start doing, it'll be Z4 plus minus plus minus plus. No, that's a lie. If it's minus there, they're all pluses, right? All pluses. When it's a plus, then it alternates, right? So when it's a minus, these are all pluses. So Z4 plus Z3I, right? So the Z goes down and the I starts increasing in power. Z squared I squared plus Z I cubed plus I4. Yeah, looking like that. And then I just gotta basically reverse the signs for I squares, right? So that becomes Z minus I, Z4, that's still positive. So I, Z cubed, that's now negative minus Z. That's minus now. I, Z plus I4 is 1. And then let me just check that this guy here, should that 1 minus minus, perfect. Therefore, because there's 2 brackets equals 0 and Z doesn't equal to I in the question, right? I'm going to write it like they told me to in the question. So reverse the order. Z squared plus IZ cubed plus Z4, 0. 2 marks. All right, pretty stock standard, 2 marks. Now, part 2, we're going to use Demoivre. All right, whenever Z5 equals to I, sorry, let's do it. Start there, equals to 0. Chuck the I over the fence, right? Always say to my students, immediately replace I with the general form of its value. So that becomes cis. Now we know I on that circle there exists over here, right? That's I there where the argument is pi on 2. So that's cis pi on 2. But I want to generalize this, right? Then I plus 2 pi k. Yeah. And then I demoivre and comment. So I'll common denominator. I won't demoivre yet. I'll common denominator plus 2, 4 now. 4 pi k on 2, and I'll bring it to 1/5. And then demoivre, bring the power inside the bracket, but also let's be amazing and factorize pi out. It becomes 4k plus 1, and when I bring the 1/5 in, becomes on 10. Right? So far so good. Where k now normally when I say to my students when it equals to 1 and it's cis 0 plus 2 pi k, I go 0 K values are 0, plus minus 1, plus minus whatever. When it's like this, I get a bit nervous. So I'm just going to go 0, 1, 2, 3, 4, right? Because I don't know whether the plus minuses give me the numbers that I want, right? But let's see how we go with these ones. It might in this case, but just in case it doesn't, sub it in and I'll just simplify thereafter. Sys, when K is 0, so I'm going at this with a bit of pace because I'm assuming that up until here it's all textbook, right? It's all sort of straightforward stuff. Sub 0 into there, I get sys pi on 10. Yeah, sys pi on 10. Let me just check this, make sure I'm on the right track. Yes, sys pi on 10. Yep, piece of cake. Sub 1 in, what's that? 5 pi. Now, when I sub that in, I'll write it as 5 pi on 10, but I'll simplify it later. So sys, that's like pi on 2, which is I. Right? Sub 2 in, sys, was that 9 pi on 10? Sys, sub 3 in, was that 13 pi on 10? And last one, sys, 17. Oops, sorry, 17 pi on 10. Yep. Now, the arguments can't be bigger than pi, so the ones I need to reduce, this guy and this guy, right? Need simplifying, yeah. So final answer, sys pi on 10. That guy there is I. That guy there is sys 9 pi on 10. Now I like these pink ones because in the next step, in the next question, I'll actually start with those pink ones. But for now, minus pi to that, I get sys, so minus 2 pi, so it'll be negative 7 pi on 10. And sys minus 20 there, 20 pi to the top, so it becomes minus 3 pi on 10. And that should be good enough for your answer to part 2. Yeah, nothing really hard about that, just really textbook, right? Really textbook so far. So let me get rid of that. Let's keep trucking. So third part, I'm going to prove this now. Check this out, right? So let me grab my answer from here, right? Because I'll start there. Right? Just zoom in. Guys, once again, what I say to my students for part 3, right, is look at the angles that they want you to deal with only. Pi on 10 and 3 pi on 10, right? Right now, I've got pi on 10, 9 pi on 10, 7 pi on 10, and 3 pi on 10. So it feels like, doesn't it? It feels like I'm going to convert this one and this one somehow using all stations central and equivalent values to make it into pi on 10 and 3 pi on 10, right? So I'm going to somehow re-establish, right, restate these ones into expressions with pi on 10 and 3 pi on 10. That's the point, right? So for part 3, right, I'm just going to say, I got these roots, right? They're all good, right? That one there and that one there is in the form. So I'm just going to explore, right? So when z equals 2, sys 9 pi on 10. Now I know, right, using all stations in central, this one here is obviously theta, this one here is pi minus theta, this one here is pi plus theta, this one here is 2 pi minus theta. I'm going to use one of these to see if I can connect it to either pi on 10 or 3 pi on 10. And for those that know, obviously I'm going to use pi minus theta, because if this guy here, right, if that angle there was, if 9 pi on 10 was equal to pi minus theta, then theta would equal to pi on 10, right? Which is the angle that I want, one of the two angles that I want. So I'm going to assume that this guy is in the second quadrant, so use the equivalent second quadrant value. And in the second quadrant now, if I sort of expanded this, right, I know that this guy is going to be cos 9 pi on 10 plus I sine 9 pi on 10, which means that in the second quadrant, right, the equivalent value, cos will be negative, so it'll be negative cos 9 pi on 10 plus, sorry, not 9 pi on 10, pi on 10, right, because I'm using the equivalent value in the first quadrant now, pi on 10. And sine would remain positive, right, sine pi on 10. Yeah, so in this case, right, this angle here, the first one here that I wanted to replace, I have done it, right? I've re-expressed it as that where the angle of pi on 10 is there, right? Done. Now, I'm hoping that this next pink part gets re-expressed to an angle with 3 pi on 10, because then I have 2 of each, right? It always works in pairs. So let's see. So this guy here was the replacement for cis 9 pi on 10, right? Great. Now let's find the replacement for this guy in terms of 3 pi on 10, right? I know that because it's negative, I'm going to use a guy before I convert it. I'm going to use this one here, 13 pi on 10, right? Yeah, which was this guy. Now, 13 pi on 10 feels like I'm going to use pi plus theta, right? Because pi plus 3 pi on 10 gets me 13 pi on 10, right? So if I explore this guy over here, so I'm just going to draw another pink arrow if you follow my arrows, right? So that would equal to z equal to, now, if I say that's 13 pi on 10, right? So let me just highlight this working out over here. If this guy here is in the third quadrant, which it is, right? Then that would be theta plus pi, and therefore theta must be 3 pi on 10, right? All right, now, so I'm going to use the equivalent value in the third quadrant. In the third quadrant, both cos and sine are negative. So minus cos 3 pi on 10 minus I sine 3 pi on 10. All right, and that is the equivalent value to cis 13 pi on 10, which was cis minus 7 pi on 10, right? So I've replaced these 2 pink ones to these ones. So now I've got 1, 2, 3, 4, 5, of which 2 of them have pi on 10s and 2 of them have 3 pi on 10s as the argument, and the other one's I, right? So now let's put it all together. So I can say something like this, right? Therefore, right, so I need a bit of horizontal space, right? So I'm just going to come over here if that's okay. Therefore, Z5 minus I can be factorized to as 5 roots, right? That's the first one, yeah? So I'll deal with the I first. And then the next ones are Z minus, now I'll write it as cis. Let me write it in long form, right? Just so I don't need to, but I want to do it for you guys just so you can see. So because pi on 10 plus I sine pi on 10, that's the first one, right? The second one now, where's his matching pair? This guy's the matching pair there, right? This guy here. So I'll be like saying Z minus, in bracket, minus cos pi on 10 plus I sine pi on 10. Yeah, now it's a bit long, right? Now the third one was Z minus. Yeah, now this one's minus, and we all know when it's a negative argument, I can express it as cos positive minus I sine positive, right? So it would be cos 3 pi on 10 minus I sine 3 pi on 10. And the last bracket, which is his matching pair, would be Z minus cos 3 pi on 10, and then minus I sine. Now, don't worry about all the negatives and stuff, right? They all would sort of come together at the end. So, but what's important for you to identify is I got Z minus I, that's cool. But then I got 2 brackets, right? Which are sort of matching, and then these 2 brackets, which are matching as well. What do I mean by matching? They got the same angle, and check this out, right? This is the next part's important. Because when I expand using rainbows, right? Let's do the green one first. Yeah, Z times Z, actually I do one over the top. Z times Z is Z squared. And then I have Z times this guy, and then this guy times Z, and this guy times his conjugate, right? They are conjugates. No, just to be absolutely clear, right? This guy here is equal to, let's have a look, right? Let's expand it, right? Z minus I, Z squared. Now, I'll do it actually off to the side, right? When I take the top rainbow, Z times this, and this guy times this, right? Actually, no, let's just do this. So I'll factorize the z out. Look what you get. You get this guy plus this guy. You can see that the causes cancel out, and I'm left with 2i sine, right? So I can actually just write 2i sine pi on 10 z, right? That's the top and the first one on z, right? And then minus times a minus, that's a plus. This guy times its conjugate, times something that looks like its conjugate. What you'll find is, guys, when you take cos pi on 10 plus I sine, you know what? I'm going to factorize. Let me just say it like this, right? So I'm going to take this guy and multiply it with this guy. But when I factorize negative from this, it'll be the conjugate. So this is how it's going to play out. I'm going to factorize a negative out from here and multiply. So it'll be like, this guy here would be a minus, and it'll be cos, sorry, I'll do it in brackets here, pi on 10 plus I sine pi on 10 multiplied by cos. I'll factorize the negative, right? So this guy is no longer minus pi on 10 minus I sine pi on 10. Now, before I do the pink, right, let me clean up the green part there. We know whenever we multiply a complex number with its conjugate, it becomes sum of the squares, right? So it becomes cos squared plus sine squared, which we all know to be 1, right? So then this bracket, right, this green bracket, which was this sort of monster 2 bracket upstairs, the blue stays the same. I'll do the pink in a second, but that becomes z minus I, z squared minus 2i sine pi on 10 z, and then minus 1. That's nice. Oops, I don't know why there's a random bracket there. Yeah. That's nice because that green there gives me comfort that that looks like what I want in the question. And then for the pinks, it's exactly the same concept. Guys, you know what? I'm sure your teacher would forgive you by shortcutting. Once you've done the long business on the green, this guy is the same. So there's cos minus. And then if I factorize a minus out there, that's the plus version, complex conjugates. You actually get exactly the same answer over here. So I'm just going to sneakily copy this over here. Oh, I can't sneakily do it because there is a subtle difference, isn't there? There's a plus there, right? So guess I got to do it, right? Let's rainbow this, right? Rainbow done that, rainbow done that, and then rainbow this guy and this guy, and then rainbow this guy and this guy. Actually, the only thing that's changing for this one is z squared. The only thing that's changing is that I just got to factorize. Maybe I'll factorize. If I turn this into a plus, and I turn this into a plus, then all these signs sort of flip around. I should get exactly the same outcome, right? Because they're minus. It looks exactly the same as the one to the left, yeah? That guy becomes a plus. That guy becomes a plus. Plus version, minus version. Guys, the only thing that's different then is this guy becomes a plus, right? When I plus them together, then the i's cancel out now. Perfect. Sine 3 pi on 10z. And then this guy times this guy is complex conjugates, and that will give you, let's see, that's a plus and minus. So then I factorize a minus out, so that's a minus, exactly the same as the green, right? So it becomes like, if I factorize, that's a plus now. When I multiply, it becomes a minus because I factorize a minus out because pi on, let's see, put a plus there. Yeah, okay, cool. So it should be exactly the same. Should be exactly the same. I can see that guy times that guy. Yep. So now they're both pluses. So I factorize a negative from the first one, right? Yep. So if I factorize negative from the first one, that becomes minus I sine 3 pi on 10. And I have no more horizontal space. Can't believe I ran out. 3 pi on 10 plus I sine 3 pi on 10. Sorry, I'll just borrow the edge there. Another bracket. And just like before, this guy here equals to 1, right? Complex conjugates, give me 1, and then I get that. Now, I wanted to do this question and not the other ones because working out for this one is so much nastier, right? And that's my pink part, and I'm done. Yeah, the working out is so much nastier than your typical roots of unity because of the minus I. Yeah, but guys, that's what you'll get as your three-parter. So just be clear in the question, and let me erase the question so I can do color. Blue is that guy, green and pink, right? And just to really play that through, when you expand this now, you can do perfect algebra and expand it, and then you'll get the same thing, but I wanted to shortcut it. You always try to match up complex numbers with its conjugate, because when you add them, right, certain parts get removed, and when you multiply them, it becomes 1, right? In this case, when you add them, because of the minuses being where they are, the real parts cancel out. Normally, the imaginary parts cancel out, right? So just keep that in mind when you're doing it. Now, once you get that for part 3, part 4 should be a very simple exercise. So let me just copy this guy over. Yeah. Now, if I'm going too quickly for you to understand, please pause the video and make sure you follow the algebra and follow the explanations, right? Because this question is actually quite a nice question. It's like an uglier version of your normal roots of unity. Now, once you get this part, how do you then use it for this part? Just feels like I'm gonna compare coefficients, right? Feels like I'm comparing coefficients. So what you do is you go, for part 4, since I've demonstrated that z minus I, right, is so factorization. So from part 1, yeah, they get that plus I z3 minus z2 minus I z plus 1. And that's equivalent to me factorizing it this way, right? So putting part 1 and part 3 all in the same question, right? Just connecting the two parts. Let's see, minus 1. Sorry, it's a bit long-winded, right? But that's why it's worth 10 marks, right? Yeah, if it's not long or difficult, yeah, it's no point on 10z minus 1, right? Now, I know that this guy and this guy are equal, so for all intents and purposes, I'm just going to get rid of them, because then I've got 2 polynomials to compare. Guys, pick a coefficient that will give you what you want. Now, I always say to my students, obviously, don't pick Z4 and 1, because you get Z4 there and 1 there. Does nothing, right? Don't do that. So I either compare the coefficients of Z cubed, Z squared, or Z. Comparing Z cubed and Z gets you sum of the roots. To get the product of the roots, which is exactly what I want here, I compare Z squared. Now, so that's just something that you find out when you do enough questions, right? If I compare coefficients of Z squared on this side, -1. On this side, to get Z squared, how do I get it? This guy times that. This guy times that. And the middle guys multiplied with each other, right? So the middle guy times that. Yeah, there's 3 parts to this, right? So Z times that, that's -1. This guy here is also -1. And the middle guy will be minus rather. 4 let's say 4 I squared, right? And then sine pi on 10 times sine 3 pi on 10. I squared then turns out, so this guy here goes away and turns it into a plus. Yeah, so 4, let me see if I got the sign right. Let's have a look. Sine, that's -2 becomes a 1. Perfect. Divide the 4 over, guys, we got it. Yeah, sometimes I make a silly mistake with the signages, but there it is. Sine 3 pi on 10 equals to 1/4. Yeah. So once you get part 3 was insane, right? With a bit of algebra, but part 4, fairly stock standard. Guys, that's a nice question. Hope you liked it. Yeah, I'll see you guys at the next video.